the potential. We have studied in gravitation that at the grassroots level, potential energy is written as minus Gmm upon r. You have studied in electrostatics that potential energy is equal to 1 upon 4 pi epsilon 0 q1 q2 upon two charges if are at a distance of r. Charges are q1 and q2. Then the potential energy is 1 by 4 pi epsilon 0 q1 q2 upon r. If we have gas molecules at large distance, they don't have any potential energy. But if they come nearer, there will be intermolecular force of attraction which gives rise to potential energy. Whenever there is a bond, whenever there is a chemical bond, because of giving or taking of electron, there is a potential energy. So many forms. So don't mistake the potential energy as just engaged. Just understand that kinetic energy is because of motion anytime. A car in motion has kinetic energy. A gas molecule in motion has kinetic energy. So anything in motion, you have kinetic energy. And anything having individual position will have potential energy. Excluding these two, there are so many forms, everyone knows. Excluding these two forms of energy, there are so many infinite forms of energy which you can think of. You can see solar energy, is it a form of energy? When I say solar energy, I mean the heat and light which is received from the sun. The energy is exuded. Every single particle of that light is traveling a tremendous distance of 1.5 to 10 raised to the power 11 kilometers as energy exuded. Significantly इतना travel करने के बावजूद उसकी energy में कोई भी कमी नहीं है. When we say kinetic energy, potential energy, the light energy, sound is also a form of energy. When we talk, we are making the air column in front of us vibrate. That's what we have done in this paper. And the vibration propagates, just like a stone put in a pot. उसमें जो waves तैयार होते हैं वो आगे जाते हैं. This is also a form of energy. Fan on होता है तो घूमता है, it's a form of energy. So you can think of indefinite forms of energy. Think of just for जाके you switch on the radio, light नहीं, silver था वो, it's a form of energy. And what are we doing actually throughout our life? Whatever we see around in our life is basically one form of energy being continuously converted into another. We feel when let us take a very simple example, a grassroots example. Right from the sun, where the energy is produced. Can we say over there energy is produced? We use the word energy is produced on the sun. Tremendous amount of heat and light is produced on the sun. But does that mean over there is a source of energy which produces it? No. If you know what happens on the sun, then you will understand that on the sun there is no creation of energy. There is no destruction of energy on the sun. When the sun emits heat and light, the phenomena is referred to as induced fusion. And what's happening over there is 4 hydrogen nuclei are combining to form a helium nucleus. In that process, there is a loss of mass, and that loss of mass is getting converted into energy. E is equal to delta n minus c squared. 1905, Einstein's equation. Energy is not produced on the sun. The one form of energy is converted into another form. The form is mass and the converted form is heat and light, or let us say electromagnetic waves. So वहाँ पे भी there is no creation of energy. There is a basic core level engineering out there where Einstein is saying mass is a form of energy. Okay, if there is a destruction of mass, annihilation is the proper word. If there is annihilation of mass, then that annihilated mass gets converted into energy. If you talk about the light coming down and getting converted via the phenomena of photosynthesis into whatever food we eat, this is basically a phenomena of conversion of energy, where carbon dioxide is taken, where water is taken, where light is taken, chlorophyll, chloroplast, वो सब मिला के photosynthesis नाम का phenomena होके that light energy is converted into chemical energy. I hope you know that's what is a chemical energy. When we eat it, that energy is utilized. We eat it in the form of carbohydrates, proteins, and fats. And whatever energy is taken in is used by the body to perform work. We are converting it into mechanical energy. So what I am trying to tell you is something very simple. Our life activity is basically a chain of activities where we are converting one form of energy to another. If you talk about the appliances which we use, if you talk about the cell activity, that is converting the chemical energy into electrical energy, that would the cell supply energy. If you talk about inverter batteries, जेव्हा MSCB कडून सप्लाय येतोय त्यावेळेला ते इलेक्ट्रिकल एनर्जी घेऊन केमिकल एनर्जी मध्ये कन्वर्ट करतात. सप्लाय गेला इलेक्ट्रिकल एनर्जी केमिकल एनर्जी परत इलेक्ट्रिकल फॉर्म मध्ये. So very significant. Throughout what is happening is one form of energy is being converted into another without annihilation, without destruction of energy. And this is the basic of thermodynamics. कोई भी एनर्जी कहीं भी किसी भी पॉइंट पे ओरिजिनेट क्रिएट नहीं होगी, कोई भी एनर्जी कहीं भी डिस्ट्रॉय नहीं होगी. The total amount of energy is always same. It's just the conversion that makes the difference. That is the hallucination we have of energy being created or energy being annihilated. At the grassroots level, it's just the conversion that makes us feel as if that's happening. And if we understand that core base, everywhere, you will use so much fuel. So fuel, everyone knows the hydrocarbons. What are the hydrocarbons doing? The hydrocarbons are the substances which are formed because of the tremendous pressure and temperature coming up from all the whatever we had, the living species which had stored energy. You just take an example. For example, after some काम कर रहे natural lava and we are like still, so हम ढूंढ नहीं रहे. Then because of the tremendous pressure and temperature, whatever energy is out there in our body will get converted into fossil. We call it fossil fuel. And after some years, someone takes it out and burns it. It will be in the form of petrol or diesel or even coal. So it's the conversion. We are not doing absolutely anything else but the conversion. And the total energy is remaining the same. ये concept जो है और work और energy जब work करते हैं तो वो energy में convert हो जाता है. तो वो interrelation जब समझ में आ जाए ये क्यों अलग-अलग पढ़ना है? Because energy में भी हम आगे देखेंगे. The word is thermodynamics. But let us first focus on this key. Energy will not be created, it will not be destroyed, it will be converted continuously to convert in the art. And in a chemical reaction, also there is conversion. In a chemical reaction, when bonds are broken, bonds are formed, and because of the breaking of bonds, for the breaking of bonds, we need to supply energy. कोई किसी भी चीज को तोड़ना है तो एनर्जी सप्लाई करनी है. और कोई भी चीज बॉन्ड फॉर्म जब होती है तो एनर्जी लिबरेट करती है. इट्स अ वेरी फंडामेंटल लॉ कि जब कभी कोई भी चीज जुड़ जाती है इन द फॉर्म ऑफ मॉलिक्यूल्स, एटम्स बाइंडिंग एज मॉलिक्यूल्स, व्हाट यू कैन से spontaneous, then energy is liberated. And when a molecule is to be broken down into form atoms, then we have to supply energy. तोड़ने की एनर्जी लगती है, जब चीजें जुड़ जाती है मॉलिक्यूल बन जाता है तो अपने आप एनर्जी लिबरेट होती है. So the first part is we need to understand the core law, that is energy is neither created nor destroyed. It's transferred from one form to another. The total amount of energy in the universe always remains the same. And we talk about universe because we treat universe as an isolated system. That is universe something which is, just imagine, I'll tell you the extent of and the scope of a universe. We are extremely small part of the planet Earth. And Earth is a negligible part of what we call the solar system. Solar system and Earth च्या size मध्ये कशामध्ये काहीच कंपॅरिझन नाही. सन ही Earth से कई हजार गुना ज़्यादा बड़ा है. That solar system, which we call as ours, is an extremely negligible part of what we call as our galaxy. The name is given as Milky Way because in the Milky Way, in a galaxy in general, there are 10 raised to the power 11 stars like sun. कुछ सन से बड़े हैं, कुछ सन से छोटे हैं, with their own solar system, with their own Earth, with their own planets, with their own meteoroids, asteroids, comets, everything. अशा 10 raised to the power 11 galaxies मिळून what we have is our universe. So you can just think of the extreme size of our universe and insignificant part played by us, and we can always hope for कि एक पूरा यूनिवर्स अगर हम एनालाइज कर पाए, और ये पूरा यूनिवर्स उसके आगे हमने डॉपलर्स इफेक्ट में पढ़ा है, लगातार अपनी साइज को बढ़ाया जा रहा है. We call it as the expanding theory of the universe. So what I was trying to tell you is a universe is treated as an isolated system, और इसलिए एनर्जी उससे बाहर भी नहीं जाएगी, उससे अंदर भी नहीं जाएगी. और thermodynamics में जाने से पहले we should clearly understand that the law of conservation of energy holds everywhere, and it holds everywhere absolutely right, 100%, but we don't have any proof. We call this as an axiom. We say two non-parallel lines meet at a point, there is no proof for it. Okay, when we talk about the law of conservation of energy, that the energy can neither be created nor destroyed, it can be transferred from one form to another. The total amount of energy in the universe always remains the same. When one form of energy disappears, equivalent amount of energy reappears. We don't have any proof for it. So we accept it as an axiom. Then what is the name of the lesson? I am defining the name of the lesson. Thermodynamics is a branch of science that deals with different forms of energy, the quantitative relation between them, and the energy changes that occur in physical and chemical processes. I repeat, thermodynamics is a branch of science that deals with the different forms of energy, the quantitative relationship between them. Quantitative relationship का मतलब आपको मालूम, mathematical relationship between them, and the energy changes that occur in physical and chemical processes. ये पूरा जो thermodynamics है, पूरा हमारा जो system है, आपल्या machines पासून सगळं हे उभे करतात. And as I told you, there is a very significant section in mechanical engineering, that is AT म्हणतात, applied thermodynamics. तर त्याच्यामध्ये सगळे heat engines असतात. Everything is a heat engine. Our body is a heat engine. It works on म्हणजे COEP ला जर तुम्ही गेलात तर COEP ला ह्यूमन बॉडी ॲज अन इंजिन असा एक विषय की आपली जी ह्यूमन बॉडी आहे ती बेसिकली एक इंजिन एक मशीन मग त्या मशीनचे वेगवेगळे पार्ट्स काय आणि ते वेगवेगळे पार्ट्स कसे काय काम करतात जस्ट लाईक a two wheeler is a machine it's an engine it has an engine और जो इंजन है it works on the principle of thermodynamics की तो काय करतो तो केमिकल एनर्जी घेतो कुठून पेट्रोल पासून त्या एनर्जी त्या पेट्रोलला बर्न करतो बरोबर पेट्रोलला बर्न केल्यानंतर ती एनर्जी जी प्रोड्यूस होते हीट त्या हीट एनर्जीला तो कशात कन्वर्ट करतो वर्क मध्ये कन्वर्ट करतो हीट एनर्जीला वर्क मध्ये कन्वर्ट करतो आणि द लॉ बेसिक लॉ इज कधी पण पूर्ण कन्वर्जन होत नाही ओके कधी पण पूर्ण कन्वर्जन होत नाही मग तो हीट एनर्जी घेतो त्याचा काही पार्ट वर्क मध्ये कन्वर्ट करतो आणि काही पार्ट रिजेक्ट करतो सो that is basically कसं होतं ते तुम्ही शिकलात की नाही माहिती नाही पण ते होतं ना कार्नॉट सायकल नावाची एक सायकल वापरली कार्नॉट नावाचा जो सायंटिस्ट त्यांनी एक पेट्रोल इंजिन कसं काम करतं एक डिझेल इंजिन कसं काम करतं टू स्ट्रोक इंजिन कसं काम करतं फोर स्ट्रोक्स असतात त्याला म्हणजे काय असतं त्याच्यामध्ये स्पार्क प्लग असतो मग पेट्रोल इंजिन असेल डिझेल इंजिनला स्पार्क प्लग नसतो तो ते कसं काम करतं टू स्ट्रोक मध्ये काय होतं फोर स्ट्रोक मध्ये काय होतं आणि सो ऑन so this all stuff our body is a thermodynamic system कारण आपण जे खातो ती जी केमिकल एनर्जी आपल्या पोटात जाते ती केमिकल एनर्जी हीट मध्ये कन्वर्ट होते आणि त्या उष्णतेवर आपलं शरीर चालतं इट्स बेसिकली अ thermodynamic system it's basically a thermodynamic closed system and we see later on what happens. But thermodynamics is a branch which deals with the conversion of energy from one form to another in a physical process or a chemical process. Physical process and chemical process म्हणजे chemical process मध्ये बद्दल आपण जास्त काम करणार आहे पण physical process चा पण आपण काही पार्ट छोटासा पार्ट बघणार आहे. Physical process म्हणजे पाण्याला आपण गरम केलं it gets converted to steam परत वरती झाकण ठेवून थंड केलं then it gets converted back to water. It's a physical process. पण जर आपण HCl आणि NaOH एकत्र केलं तर NaCl आणि H2O तयार होईल परत उलट कन्वर्जन पॉसिबल नाही आहे it's a chemical reaction because the reaction has already taken place fine so thermodynamics जो है हम और थोड़ा डिटेल में अगर जानने की कोशिश करेंगे तो समझ में आएगा कि थर्मोडायनामिक्स के कुछ लिमिटेशन क्या लिमिटेशन thermodynamics does not talk about please pay attention the limitation of thermodynamics I repeat thermodynamics is a branch which deals with the quantitative relationship between the heat changes which are happening in a chemical or physical process the limitations are it does not talk about the rate of a reaction कोई भी हो किस रफ्तार से होगी प्लीज पे अटेंशन मैं आता मुद्दाम एक का धड्याची लिंक सोडतोय रिएक्शन किस रफ्तार से होगी उसके बारे में कोई मालूमात एक थर्मोडायनामिक प्रोसेस से नहीं हो सकती हाउ फास्ट द रिएक्शन वुड occur cannot be found out by studying thermodynamics उसके लिए अलग से लेसन chemical kinetics I hope you understand I'm putting up a link over there कि thermodynamics talks about कोई रिएक्शन होगी क्या अगर ये होगी तो इस रिएक्शन के लिए हीट सप्लाई करनी पड़ेगी या अपने आप होगी अगर कोई रिएक्शन अपने आप होगी तो थर्मोडायनामिक्स टॉक्स अबाउट कि इस रिएक्शन में एनर्जी मिलेगी तो कितनी मिलेगी और क्या मिलेगी बट इट डज नॉट टॉक अबाउट रिएक्शन किस रफ्तार से होगा whether it will take 1 minute 1 second or 1 hour for the completion is not something which is revealed by thermodynamics in order to understand कि कोई रिएक्शन किस रफ्तार से होने वाली है we need to understand chemical kinetics. Number 2, इसका मतलब ये है thermodynamics is not interested in the process, it is interested in the it is only interested in the starting point and the destination. क्या था, क्या मिला है, संपलं. असं जर झालं तर एनर्जी इवॉल्व होईल, एवढी होईल आणि ऑल दॅट स्टफ वेरी नाईस. बट इट विल नॉट टॉक अबाउट की इथून इथला प्रवास कसा आहे. Thermodynamics talks about the starting point and the destination. It does not talk about the entire process. For example, SN1, SN2 mechanisms do not come under thermodynamics. They come under the mechanisms of stuff which is not included in thermodynamics. Number 3, thermodynamics. These are the limitations. And thermodynamics, number 3, limitation number 3. Thermodynamics deals with macroscopic systems. Macro और micro, ये दो लफ्ज में अंतर है. Microscopic system म्हणजे अतिशय छोटे आहे. Okay, let us say a system which involves 100 electrons or 200 protons and something like that is a microscopic system. Chemical thermodynamics generally talks about macroscopic system, that is 1 mole of substance, 2 moles of substance and something like that. So these are the 3 limitations, if you want to call them limitations of thermodynamics. That number 1, thermodynamics gives no information regarding the rates of a reaction. Number 2, it deals only with the initial and final states of the system. And number 3, thermodynamics deals only with the macroscopic problem. Fine. इसके आगे चलते हैं और ये इंट्रोडक्शन के बाद हम कुछ स्पेसिफिक टर्म्स को समझने की कोशिश करेंगे. What is the system? What is the surrounding? What is the boundary? And what is universe? What is the system, surrounding, boundary and universe? The part which is under thermodynamic consideration. Thermodynamic, आता thermodynamic म्हणजे काय की there will be some heat changes which are occurring. Heat दी जाएगी. Thermodynamics मध्ये basically काय होणार? आपल्या धड्याचं नाव काय म्हणतात बघूया. Thermodynamic, chemical thermodynamics and energetics. Okay. तर chemical thermodynamics and energetics हा जो शब्द आहे, chemical thermodynamics एखाद्या chemical reaction मध्ये जे पण थर्मल चेंजेस होतील ते बघणार है. एक किसी केमिकल रिएक्शन में जो भी थर्मल चेंजेस होंगे, हीट सप्लाई की जाएगी तो कितनी सप्लाई की जाएगी, इवॉल्व होगी तो कितनी होगी, ये सब दिख रहा है. और एनर्जेटिक्स इज अ शॉर्ट नेम फॉर केमिकल थर्मोडायनामिक्स. तो सिस्टम क्या है? The part where the thermodynamic changes are occurring, यानी जहाँ रिएक्शन हो रही, that is called as system. म्हणजे जर तुम्ही एक काचेचं भांडं घेतलं, please understand now I am telling you in terms of the practical stuff which you have done in the last 2-3 weeks. Important ये वीक में, ये पूरे वीक में आपको कहीं भी प्रैक्टिकल के लिए नहीं आना है. This week we are giving break because हमको वो जो फिजिक्स के apparatus है, सेल्स बनाने की वो नहीं मिले. We have ordered possibly we will be getting it by the end of this week. The part which is under thermodynamic consideration is called a system. म्हणजे काय? तर तुम्ही एक भांडं घेतलं, एक फ्लास्क घेतला, त्याच्यामध्ये एक सील टाकलं, त्या एक सील मध्ये तुम्ही NaOH टाकलं, तर ते जे भांडं आहे त्याच्या आतमधला भाग, ते जे भांडं आहे त्याच्या आतमधला भाग we refer to it as a system. समझ में आया? This is the part which is under thermodynamic consideration, or this is the part where the thermodynamic changes are going to occur. यानी टेम्परेचर बढ़ेगा, कम होगा, something like that. Everything excluding the system is referred to as the surrounding. Everything excluding the system is referred to as the surrounding. What separates a system and a surrounding is called as the boundary. म्हणजे तो जो फ्लॅग घेतला आहे तुम्ही काचेचा, त्या काचेच्या ग्लासची बाउंड्री म्हणजे तो काचेचा ग्लास असतात त्याची जी पेरिफरी that is called as the boundary. And system, surrounding and boundary together contribute a thermodynamic universe. System, surrounding and boundary हे तीन पण एकत्र we say it is universe. तो प्रॉब्लम है इसको हमको सिस्टम के बारे में ही पढ़ना है. Surrounding, boundary, universe, we are hardly interested. We try to understand types of systems. Systems को अलग-अलग तरीके से क्लासिफाई किया जाता है. Open, closed and isolated system. Open, closed and isolated system में क्या है? तो open system is a system which can exchange energy as well as matter with the surrounding. पाणी घेतलं, एका भांड्यामध्ये पाणी घेतलं आणि पाणी उकळतोय. तर पाणी जेव्हा उकळतोय तर ती हीट बाहेर पडतीये का? तो there is exchange of heat. Yes. पाणी जेव्हा उकळायला लागतं त्यावेळेला ते पाणी जे आहे त्याचं वेपर होतात, ते वेपर पण बाहेर पडतात. So it is open system because it is able to exchange energy as well as matter with the surrounding. It is an open system because it can exchange energy as well as matter with the surroundings. वरती झाकण टाकून दिलं, वरती जर झाकण टाकून दिलं तर काय होईल? तर वरती जर झाकण टाकून दिलं तर सिस्टम कॅन एक्सचेंज एनर्जी. येस, कारण जे झाकण टाकलेलं आहे दॅट इज अ कंडक्टिंग वॉल. स्टेनलेस स्टीलचा जर भांडा असेल इट कॅन बी कंडक्टेड आउट, सो इट कॅन एक्सचेंज एनर्जी. बट कॅन इट एक्सचेंज मॅटर नाउ? वरतून झाकण टाकून दिल्यामुळे इट कॅन नॉट एक्सचेंज मॅटर अँड वी से इट इज अ closed system. सबको समझ में बराबर है इसको. आणि तेच आता आपण गरम पाणी आपण एका थर्मस फ्लास्क मध्ये ठेवून दिलं. तो थर्मस फ्लास्क काय करतो? एनर्जीला बाहेर पडणे जाऊ देत, बाहेर टाकतो म्हणून चहा गरम राहतो. फॉर कंपॅरेटिव्हली नॉर्मल थर्मस फ्लास्क जो it will not allow the exchange of matter, neither it will allow the exchange of energy. So system which will not allow the exchange of energy or matter with the surrounding is referred to as an isolated system. Any problem? नहीं समझ रहे? Properties of system. System quality and the system property. There are two properties of systems which we need to study. One is intensive property and second is extensive property. One is intensive property and the second is extensive property. Intensive property is the property of system